We are going to start now the next lecture, lecture 6 of chapter 4, class 12th mathematics, determinants. And in this lecture, we will talk about the system of linear equations and how to solve them using the determinants. So first thing we are going to discuss over here, it is the Kramers rule. This is the first method we are going to talk about. So if we consider that we are given a system of equation means this is first equation, linear equations we are talking about, it is a1x plus b1y plus c1 is equal to 0, and the second equation is a2x plus b2y plus c2 is equal to 0. Over here x and y, these are unknown, and a1 b1 c1 a2 b2 c2, these are constants, and we have a1 over a2 is not equal to b1 over b2. We will see in our next slides that why this condition is there. We will see on our next slides. So by cross multiplication, we know that the solution for this is x over b1 c2 minus b2 c1, that is equal to y over c1 a2 minus c2 a1, that is equal to 1 over a2 b2 minus a1 b2 minus a2 b1. This is by cross multiplication method. For details of this method, you can refer to the videos of linear equations that are present on our channel of class 10th. And if we look carefully at these values we are talking about, this is basically the determinant b1 c1 b2 c2. This is the determinant c1 a1 c2 a2, and this is the determinant we have, it is a1 b1 a2 and b2. So what we can see from this is that if this is the system of equations given to us in the unknowns x and y, then the values of x and y, they are given by these equations. We are talking about these equations over here, that is x is equal to this and y is equal to this. So this is the Kramers rule for 2 cross 2 systems, or we are saying 2 equations and 2 unknowns are there, and this condition is important over here, that a1 over a2 is not equal to b1 over b2, and this is basically because of this condition. We are saying, we are talking about this condition over here, otherwise this term will become, denominator will become equal to 0. So because of this condition, we are using this condition over here. Now if we extend this method for 3 cross 3 system, means 3 cross 3 means we are talking about now we have 3 equations and 3 unknowns. This is first equation, second equation and third equations, and there are 3 unknowns over here. We are talking about the unknown x, y, z, x, y, z, x, y and z. Now to solve this kind of system, we are going to write the determinants over here as we have written in the previous case. So we have the system a1x plus b1y plus c1z is equal to d1. Then we have a2x plus b2y plus c2z is equal to d2. Then we have a3x plus b3y plus c3z is equal to d3. We can write this system as ax is equal to b, where a is the matrix we are saying a1 b1 and c1 is the matrix a1 b1 and c1, a2 b2 c2, a3 b3 and c3. This x is the matrix we are saying, it is x y z, and d is the this b is the matrix we are saying, it is d1 d2 and d3. So we are saying, writing these 3 equations, it is equivalent to writing the equation ax is equal to b, where this a is equal to this matrix, x is equal to this matrix and b is equal to this matrix. Now to solve this, we are writing this particular a we are talking about, we are writing it is equal to delta. This thing is mentioned over here. How we are solving by Kramers rule, we are writing this value as delta. Next we are writing delta 2. This is another determinant we are talking about. We are writing delta 2. And what we have done, look at this first column over here. It is A1, A2, A3. In place of A1, A2, A3, we have replaced it with D1, D2, D3. We have replaced this first column with D1, D2, D3 to obtain delta 1. Next, to obtain delta 2, when we are talking about delta 2, we have replaced the second column with D1, D2 and D3, and to obtain delta 3 we have replaced this third column. We are talking about this third column we have replaced with D1, D2 and D3. So we are having four determinants now. One is this delta, then delta 1, delta 2 and delta 3. These are the determinants that we have to calculate, and based upon this we are saying if delta is not equal to 0, because the answers we are having over here, in these answers we have delta in the denominator. So if delta is not equal to 0, then the value of x will be given by delta 1 by delta. Delta 1 is this determinant that we have calculated divided by delta. Y will be given by delta 2 by delta, and z will be given by delta 3 by delta. So this is just the extension of the previous method that we have done, the Kramers rule for 2 cross 2 equation. This is for 3 cross 3 system. Why 3 cross 3? Because the matrix over here, it is 3 cross 3 matrix. So we call this kind of system the 3 cross 3 system. So the solution, to obtain the solution, we have to calculate these four determinants, and if delta is not equal to 0, then the value of x, y, z, they are obtained in this way. Now next we have is the nature of the solution of system of linear equations. So we know that when we are talking about the nature of the solution, we are having two cases. One is consistent and second is inconsistent. Inconsistent means it has no solution, and when we are talking about consistent, it has two cases. One is the unique solution and second is it has infinite solution. So in the first case we are considering when delta is not equal to 0. Delta we have already seen, it is the determinant we are talking about of the matrix A1, B1, C1, then A2, B2, C2, then A3, B3, C3. We are saying if this value is not equal to 0, then in that case the values of x, y and z, we obtain the value of x is equal to delta 1 by delta, it is unique value. We obtain the value of y is equal to delta 2 by delta, and we obtain the value of z is equal to delta 3 by delta, where delta 1 is obtained by replacing this first row by d1, d2, d3, then delta 2 is obtained by replacing this second row, and delta 3 is obtained by this z is obtained by replacing the third row with, we replace this element with d1, d2 and d3. These elements, these are replaced, we have seen on our previous slide. So in this case we are saying the system is consistent and it will have a unique solution. So we are talking about the case that the system is consistent and it will be unique when delta is not equal to 0. Coming to the second case, when we are saying that delta is equal to 0, then in this case there are two sub cases. First is that one of delta 1, delta 2 and delta 3 is non-zero. We are saying the value of delta we have, that is equal to 0. Now suppose delta 1 is not equal to 0. So what we get is that delta 1 is equal to x times delta. Now look at these conditions over here. We are saying delta is not equal to 0. This delta is equal to 0. This value is equal to 0. And delta 1 is not equal to 0. This value is not equal to 0. And we want to find such a value of x. So clearly we cannot have any x which when multiplied with 0 will give us a non-zero answer. So we are saying no such x is possible. Similarly, if we are saying delta 2 is not equal to 0, then in this case we will have delta 2 is equal to y times delta. This term is equal to 0, this is not equal to 0, so there is no such y possible. No such y is possible, for which if we multiply it with 0, the answer we obtain it is non-zero. So we are saying that if at least one of delta 1, delta 2 or delta 3 is non-zero, then the system will have no solution, the system is inconsistent. So we are talking about the case over here, inconsistent, no solution. So no solution will be there if delta is equal to 0 and at least one of these three, delta 1 or delta 2 or delta 3, at least one of these three is non-zero. The next case we have is, we are saying that delta is equal to 0, we are considering the case delta is equal to 0 and delta 1, delta 2, delta 3, all these three are also equal to 0. Then what we can see is the value of delta 1 we have it is x times delta, the value of delta 2 we have it is y times delta, and value of delta 3 we have it is z times delta. We have the values of delta that is equal to 0, values of delta 1, delta 2, delta 3 is equal to 0. So there can be infinite possible values of x, y and z for which this thing can happen. Why we are saying, we are not saying for all values of x, y, z, we are saying there are infinite values of x, y, z because these three, these are connected by the relation x1 a1x plus b1y plus c1z is equal to d. So if we are talking about suppose this equation, then what we will get, that 2 of x, y and z, any two of these will depend upon one of these. If we are talking about x and y, it will depend upon z, or we are saying y and z, it will depend upon x. So basically we are saying we will have infinitely many solutions. So the system will be consistent and it will have infinite number of solutions. So for infinite solutions, we are saying delta is equal to 0 and delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. So these results, these are summarized over here. We are saying if delta is not equal to 0, the system has unique finite solution and it is said to be consistent. If delta is equal to 0, we are having two cases. First is if delta 1, delta 2, delta 3, any one of these is non-zero, then the system will have no solution. And if all these four, delta 1, delta 2, delta 3 and delta, all these four, these are equal to 0, the system will have infinite number of solutions. Now next we have to solve the following system by using the Kramers rule. So the first equation that is given to us is x plus y is equal to 4 and second is 3x minus 2y is equal to 9. So the value of delta that we will have, we are writing the equation x plus y is equal to 4 and 3x minus 2y is equal to 9. So the value of delta we have it is 1, 1, 3 minus 2. Value of delta 1 will be 4, 9, 1 minus 2. How we are writing this value? This first row it is replaced with 4, 9. Next we are talking about the value delta 2 is equal to 1, 3 and 4, 9. Now in this case this 1, 3 is replaced with 4, 9. So if we solve all these determinants, we obtain that the value of delta is equal to minus 5, which is not equal to 0. It means system is consistent and will have unique solution. When you solve this, you will get it is minus 17, and when you solve this, this is minus 3. So the value of x we have it is delta 1 over delta, that is minus 17 by minus 5, that is equal to 17 by 5, and y is equal to delta 2 by delta, that is equal to minus 3 by minus 5, that is equal to 3 by 5. Next is this 3 cross 3 system is given. So we have x plus y plus z is equal to 9. 2x plus 5y plus 7z is equal to 52 and 2x plus y minus z is equal to 0. So if we write the values over here, the delta, it is 1 1 1 2 5 7 and 2 1 minus 1. We are talking about these coefficients over here. It is 1 1 1, then it is 2 5 7, then it is 2 1 and minus 1. Next we are talking about the delta 1. So to write delta 1, what we are going to do is this, look at this first column over here, we are going to replace it with these values. So the value of delta 1 that we will have, it will be 9 52 0 1 5 1 and 1 7 minus 1. Next, when we are writing delta 2, we are writing it is 1 2 2 and 1 7 minus 1. Both these are now same, and this middle column we are talking about, it will have the value 9 52 and 0. And similarly, when we will write the value of delta 3, this third column it will be replaced with this value, and the answers for this, the value of delta, it is minus 4. When you calculate this determinant, the answer is minus 4 and it is non-zero. Then you calculate delta 1, answer is 52. You calculate delta 2, answer is 16. You calculate delta 3, answer is minus 20. So when we solve these values, we get value of x is delta 1 by delta. So the answer you obtain it is 1. Value of y it is delta 2 by delta. The answer is 3. And the value of z it is minus 20 by minus 4. The answer is 5. So the final answers we have, it is x is equal to 1, y is equal to 3 and z is equal to 5. So we have just substituted the values in the Kramers rule and we obtain this answer. Next is find the values of p and q such that the system of this equation will have unique solution, infinitely many solutions and has no solution. So again we are writing the values of delta, delta 1, delta 2 and delta 3. We have solved these determinants. For delta we have obtained the value, it is p minus 1. For delta 2 we have obtained the value for delta 1 and delta 3. We have obtained written these determinants and we have solved these determinants to obtain these values. So how we are writing these terms, it is 1 1 1, this is coefficient of x, then 1 2 2 coefficients of y, then it is 1 3 p, these are coefficients of z. Next, in the next we have replaced it with 6 10 and q. We have replaced the first column, then we have replaced the second column, then we have replaced the third column. Determinant you already know how we can calculate. You can simplify using the properties and solve the determinant, or you can directly calculate the determinant using the expansion. Now the first part we have is that it should have a unique solution. So in the case of unique solution, we know that the value of delta should not be equal to 0. So when we equate this not equal to 0, so we are saying that p should not be equal to 3. So we are writing that p belongs to the set x belongs to R and x is not equal to 3. So it can be any real number except for 3. And q can have any value. The value of q does not put any effect on the value of delta. So q can have any value. So we are saying that p is not equal to 3 and q belongs to R. Second is it has infinitely many solutions. So when we are saying infinitely many solutions, the condition we have is that delta should be equal to delta 1 should be equal to delta 2. All these terms, these should be 0. So we have p minus 3 should be 0. 2p plus q minus 16 should be 0. 4p minus 2q plus 8 is equal to 0. And q minus 10 is equal to 0. So this implies us p is equal to 3. This implies us q is equal to 10. This last equation This implies us q is equal to 10. And if we put in these equations, suppose we put these values in this equation, we are getting 2 into 3 plus 10 minus 16 is equal to 0. It is satisfying this equation. If you put in this equation, we are getting 3 into 4 minus 2 into 10 plus 8, that is equal to 0. So we are saying that these values of p and q, they are satisfying these equations. So for p is equal to 3 and q is equal to 10, all these conditions are satisfied. So we are saying the system will have infinitely many solutions for this case. Last is the case of no solution. So for no solution, we are saying delta should be equal to 0. So when we put delta is equal to 0, so this thing implies us that p is equal to 3. And we are saying that at least one of these three should be non-zero. So if we put p is equal to 3 in these equations, we will get it is equal to q minus 10. First equation will come in this form. Second equation will become 20 minus 2q, and the third equation will become q minus 10. So we are saying that at least one of them should not be equal to 0. These should not be equal to 0. So what we are getting is that q should not be equal to 10. From all these three equations, we are getting q should not be equal to 10. So we are saying that this system will have no solution when p is equal to 3 and q is not equal to 10. Next is condition for consistency of three linear equations in two unknowns. Now we are talking about, in the previous case we were having three unknowns and three equations. Now we are having two unknowns, x and y, and number of equations we have there 3. So to solve these kind of equations, we are saying, suppose we are considering these two equations. Then the solution by Kramers rule we have x is equal to the value should be determinant of b2c2 b3c3 divided by determinant of a2b2 a3b3. We are considering these two systems in two unknowns, and the value of y we will have, it is determinant of c2a2 c3a3 divided by determinant of a2b2 a3b3. Now for solution to exist, these values of x and y, they should satisfy this equation. So if we substitute these values over here, we will obtain that a1 into determinant of b2c2 b3c3 plus b1 into determinant of c2 a2 a3 c3 b3 a3, that should be plus c1 into determinant of a2 b2 a3 b3, this should be equal to 0. These values of x and y, they should satisfy this first equation, and this is just equivalent to writing a1 b1 c1 a2 b2 c2 and a3 b3 c3, determinant of this term is equal to 0. So we are saying that if we have three equations in two unknowns, then the condition for the consistency, that is condition for the solution to exist, is that this determinant should be equal to 0. That is a1 b1 c1 a2 b2 c2 and a3 b3 c3 should be equal to 0. Next is, we have to find the value of lambda for which this system of equation is consistent. Now if we look at this system of equations, there are three equations and number of unknowns we have there 2. So for, we know that the condition for consistency is that 1 minus 3, we are writing the coefficients over here, coefficient of x, y, and this is minus 3. Then it is 1 plus lambda, 2 plus lambda and minus 8. It is 1 plus lambda, 2 plus lambda and minus 8. And last it is 1 minus of 1 plus lambda. and it is 2 plus lambda, this determinant should be equal to 0. Now to solve this determinant, we have applied these transformation, that column 2 approaches column 2 minus column 1, column 3 approaches column 3 minus 3 times column 1, and we obtain that these two elements over here, these will become 0, and these terms, these are changed accordingly. You can try at your own to solve this, and we obtain that these terms are changed accordingly. Now if we open this determinant along this first row, we obtain that this determinant reduces to a 2 cross 2 determinant. On solving this determinant, we obtain a quadratic equation in lambda, and the solution of this quadratic equation in lambda comes out to be, lambda is equal to 1 or lambda is equal to minus 5 by 3. So these are the values of lambda for which this system of equation, this will be consistent. Next we are talking about the system of homogeneous linear equations. So in the previous case we were talking about the system, we have written Ax is equal to b. A was the coefficient matrix, we are writing a1, b1, c1 like this, and x is equal to x, y and z, and this b we are saying it was equal to d1, d2, d3. Now we are talking about the case if this matrix D, B we are talking about, all these entries, these are 0 entries. So the system of equation will become Ax is equal to 0. This is basically the 0 matrix we are talking about. So this kind of system in which this matrix B, it is 0 matrix, it is called the homogeneous linear system. Homogeneous linear system means that these constants in the equation, they are 0. So we have written this equation in the form a1x, b1y, c1z is equal to 0. Then a2x, b2y, c2z is equal to 0. Then a3x, b3y and c3z is equal to 0. So constant terms over here, they are 0. So clearly what we will have, the value of delta we have, it is a1, b1, c1, a2, b2, c2 and a3, b3, c3, and the values of delta 1, when we replace this column with 0, 0, 0, that will be 0, delta 2 will be 0 and delta 3 will be 0. So one thing is clear, that if we are talking about the values of delta, we are having two cases now, either the value of delta will be equal to 0 or the value of delta is not equal to 0. Now if the value of delta is not equal to 0, we know that it will have a unique solution, and that solution will be given by the value 0, 0 and 0. This is the only solution in this case. We are saying the value of x we will obtain, that will be 0, value of y we will obtain is 0, and value of z will be 0. And second case we are talking about when delta is equal to 0 and delta 1, delta 2, delta 3, all these values are also equal to 0. In that case the system will have infinitely many solutions. This kind of solution, this 0, 0, 0, this is called the trivial solution, and these infinite solution, these are called the non-trivial solutions. So to obtain the answer, we are saying, this thing is mentioned over here, we are saying if delta is not equal to 0, then x is equal to y is equal to z is the only possible solution, and the system is said to have trivial solution. The case if delta is equal to 0, then at least one of x, y, z is non-zero, and the solution is said to be non-trivial solution. So what we get is, if we solve these two equations, we are talking about last two equations, if we try to solve these two equations, we are talking about these two equations we are trying to solve, the answers for x, y and z we obtain in this way. Answers for x, y, z we obtain in this way. If we equate this value is equal to k, we are equating this value is equal to k, so the value of x, y, z we obtain in this form. x is equal to k times this determinant, y is equal to k times this determinant, z is equal to k times this determinant. So these values should satisfy this first equation. So we substitute these values in the equation a1x b1y plus c1z is equal to 0. So when we substitute these values in this equation, we obtain that delta is equal to 0, or the determinant of a1 b1 c1 a2 b2 c2 and a3 b3 c3, it is 0, and this is the case of non-trivial solution. So what we have obtained, that when delta is equal to 0, delta 1, delta 2, delta 3 are all equal to 0, then we have infinite solutions, and this is the case of non-trivial solutions, because when delta is not equal to 0, we have the unique solution, that is the 0 solution, and this 0 solution is called the trivial solution, and this thing is explained over here. The trivial solution means the 0 solution in this case, and non-trivial solution means that we have infinite solutions in which at least one of x, y or z is non-zero. At least one of them is non-zero. That case is called the non-trivial solution. So these are the conditions for existence of the solution, or the trivial and non-trivial solutions in case of homogeneous equations. Now the next question we have is, find all values of lambda for which the equations, these are the equations given to us, these equations should possess non-trivial solution, and find the ratios x, y, z, where lambda is the smallest of these values. So first thing that we will note over here is that the constant term in these cases, these are the terms with x, y, z, and constant terms in all these three cases, we have it is equal to 0. So this system of equation, this is homogeneous system, and we know that it will have non-trivial solution if the determinant of the coefficient matrix, it is written over here, it is lambda minus 1, then 3 lambda plus 1, and then it is 2 lambda. Next it is lambda minus 1, 4 lambda minus 2, and lambda plus 3, and last it is 2, 3 lambda plus 1, and 3 into lambda minus 1. This determinant should be equal to 0. So when we solve this determinant, we have applied the row operations over here first, that row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So we obtained these two values are 0, and these values, these are changed accordingly. You can apply these operations and see that what answer that you should obtain this kind of matrix. After that, we have applied the operation that column 3 approaches column 3 plus column 2. So on applying this operation, we obtain this is 0, this is 0, and these three terms are 0. Then we have opened this determinant along the second row, and we obtain the answer in this form. When you open the determinant along the second row, you will obtain the answer in this form, and on simplifying these values, we obtain that the value of lambda we have there is equal to 0 or 3. So we are saying these are the values of lambda. First thing that we have to calculate in this question, it is find all values of lambda for which this system possesses non-trivial solution. So we are saying for lambda is equal to 0 and 3, this determinant will be equal to 0. It means this system will have a non-trivial solution. Next thing we have to do is find the ratios of x, y, z, where is lambda is the smallest of all these values. So smallest of all these values is, we are talking about lambda is equal to 0. So when we substitute lambda is equal to 0 in these equations will become, the first two equations we are talking about, they will come in this form. So we are getting it is x minus y is equal to 0, x plus 2y minus 3z is equal to 0. Now if we use the Kramers rule, we obtain x over determinant of this term, then y over determinant of this term, and then z over determinant of this term. These are equal. So the ratio of x, y and z, we obtain it is 1:1:1. Next we have is given the system of equations in this form. So the first equation we have, it is x is equal to this, y is equal to this, and z is equal to this. We can write these equations as x minus c y minus b z is equal to 0. Then it is cx minus y plus az is equal to 0. And last equation we have, it is ay, in place of ay we should write it is bx plus ay minus z is equal to 0. Where x, y, z are not all 0, then prove that the system has non-trivial solution if this value is equal to 1. And we know that this system will have non-trivial solution if the determinant, the coefficient over here, it is 1, 1 and 1. So we are writing it is 1 minus c minus b, then c, and then this value we will have it is minus 1, and this value we will have it is minus a. These coefficients will be b, a and minus 1. It is given that this determinant is equal to 0. You might have noticed over here that the values we are writing over here and the values we have written over here, these are of opposite sign, because the equations we are considering in this case, it is minus cx plus y minus az is equal to 0, and both these equations, these are equivalent. So to solve this determinant, either you can solve this or this. We have used the operation that column 2 approaches column 2 plus c times column 1, column 3 approaches column 3 plus b times column 1. We obtain both these elements are 0. We open this determinant along this first row, we obtain the answer in this form. And on solving this, we will obtain that a square plus b square plus c square plus 2abc is equal to 1. Now next we have is to solve the system of linear equations by matrix method. So we have already seen these definitions in our previous slides, that a system is said to be consistent if it has one or more solution, that is solution exists, and it is said to be inconsistent if there is no solution. So if we are talking about the equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3, then we can write the matrix A as, these are the coefficients a1, b1, c1, we are writing over here. Then we have the coefficients a2, b2, c2, these are the coefficients we have written over here. And then we are talking about the coefficients a3, b3 and c3. This is the matrix A. The matrix X, we are saying it has the element x, y and z, and B, capital B is the matrix we are writing, it is d1, d2 and d3. So these are the column matrices. So we can write this system of equation, these system of equations in this form, that it is ax is equal to b. So if we multiply these terms, this will be multiplied with this column. So the first multiplication will give a1 x, b1 y, c1 z. Then it will be a2x plus b2y plus c2 z. Then a3x plus b3y plus c3 z. We obtain this matrix. You are saying this is a 3 cross 1 matrix. This is a 1 cross. This is 3 cross 3 matrix, and this is a 3 cross 1 matrix. So the answer we are obtaining over here, that will be a 3 cross 1 matrix, and it is equal to d1, d2, d3. So what we are getting, this term. When we equate these values, this is corresponding to this first equation, this is corresponding to the, this corresponds to the second equation, and this corresponds to the third equation. So we are saying these are the three equations, and we can write it in this form, and it is Ax is equal to b. We are writing, sometime we write it small x and small b. So both the notations we can use. So based upon this, we are saying the first case now we are going to discuss, it is when determinant of A is not equal to 0. So when determinant of A is not equal to 0, in this case A inverse will exist. We are saying when determinant of A is not equal to 0, it means A is invertible, A inverse will exist. So we have the equation Ax is equal to b. We multiply both sides of this equation with A inverse because it exists. So what we are getting, x is equal to A inverse of b. So x is the unknown, x is the unknowns. So we are saying we can obtain the value of the unknowns using this, and since A inverse is unique, so the system has a unique solution. So we are saying what we obtain is that when A determinant of A is not equal to 0, the given system is consistent and has a unique solution. Next we have is when determinant of A and adjoint of A into B is not equal to 0. We are saying both these values, these are not equal to 0. So what we get is, in this case the given system has no solution and hence it is consistent. So basically we are saying when determinant of A, this is equal to 0, the condition we have is the determinant of A is equal to 0 and adjoint of A into B is non-zero. I am again writing these conditions over here, the determinant of A is equal to 0 and adjoint of A into B is not equal to 0. In this case we are saying the system has no solution and we know it is called inconsistent system. And the third case is when determinant of A is 0 and adjoint of A into B is equal to 0, then we are saying the given system has infinitely many solutions. In this case the given system has infinitely many solutions. Based upon this, we are going to solve certain problems. So first is this 2 cross 2 system is given. These two equations, these are given. So we can write these equation as 2x plus 5y is equal to 7 and 6x plus 15y is equal to 13. So the coefficient matrix we have over here, it is 2, 5, 6 and 15. The constants the unknowns we have, it is xy, and the constant terms we have, it is 7 and 13. So we are saying that this system we are writing, it is basically Ax is equal to b. So if we calculate determinant of A, the answer we obtain, it is 2, 5, 6 and 15. So that is equal to 30 minus 30 is equal to 0. So we are talking about the case that determinant of A is equal to 0. So next thing we have to do is we have to calculate the value of A adjoint A into B. Now the value of adjoint A we have, this is the matrix we have. So the value of adjoint A will be 15 minus 5 minus 6 and 2. We multiply it with the matrix B. We are talking about this 7 comma 13. This matrix we are talking about, we are multiplying it with 7, 13. The answer we obtain, that is equal to 40 comma and minus 16, which is not a null matrix. So what we obtain is, in this case we are saying that determinant of A is equal to 0 and adjoint of A into B is non-zero. So we obtain that the system, the given system of equations is inconsistent. That is, there is no solution. There is no solution in this particular case. Next is this system of equation is given. So there are three equations and three unknowns are there. So when we write this in the form Ax is equal to b, we are writing the matrix A is 3, minus 1, 2. Look at these terms over here. It is 3 minus 1 and 2. The next term we will have it is 2, 1 and 3, and next it is 1 minus 2 and minus 1. We are multiplying it with x, y and z. These are the three unknowns, and the constant term we have over here, they are 3, 5 and 1. So we have written the equation in this form. Now if we calculate the value of determinant of a, the answer we have it is 3 into minus 1 plus 6 plus 1 into minus 2 minus 3 plus 2 into minus 4 minus 1. On solving this, the answer we are obtaining it is equal to 0. So again we are saying this system may be consistent or may have infinite solution, or it may have no solution. So we have to calculate, the next thing we have to calculate it is adjoint of a into b. So when we calculate the adjoint of a, its value is 5 minus 5 minus 5. Then it is 5 minus 5 minus 5. Then it is minus 5, 5 and 5. You know how we calculate the adjoint? We write the cofactors corresponding to each term, and then we take the transpose. And the value of b we have it is, in this case it is 3, 5, 1. So when we multiply both these, the answer we obtain it is minus 15 and 15, and this is not equal to the null matrix. So again we are getting that determinant of a is 0, adjoint of a into b is non-zero. So the given system of equations is inconsistent. We have obtained that the given system of equations is inconsistent. Next is this system of equation is given, so we have to solve it using the matrix method. So we are saying we can write this as 2, 5, 3, 2. These are the coefficients over here, 2, 5, 3 and 2. Then the unknowns are x and y. There are two unknowns, and the constant terms they are 1 and 7. So we have written this in the form ax is equal to b. Now if we calculate the determinant of a, the answer we have it is 4 minus 15, that is equal to minus 11, and it is not equal to 0. So we are saying that a inverse exists, and the value of a inverse will be 1 over minus 11, that is determinant of a, into adjoint of a, that will be 2 minus 5 minus 3 and 2. So this is a inverse. So again talking about this equation, if we multiply with a inverse on both sides, we obtain that the value of x is a inverse into b. So the value of x we obtain it is minus 1 by 11, 2 minus 3 minus 5, 2, into the value of b we have it is 1 and 7. On multiplying all these terms, we will obtain the answer as we have minus 1 by 11 over here. So the answer we are obtaining that is equal to, when you multiply these terms, it is 2. The answer we are obtaining it is 2 minus 35, and the next value we will have it is minus 3 plus 14. So the values we obtain from this, it is, and this is equal to minus 1 by 11. Minus 1 by 11 is already there, and this is minus 33, and this value we have it is equal to 11. So the answer we are obtaining it is equal to 3 and minus 1. So what we get is that xy is equal to 3 and minus 1. So this gives us the value of x is 3 and the value of y is minus 1. Now in this next question we are given that if a is equal to, we are talking about this matrix A is given, these are the entries over here, and we have to find A inverse, and hence we have to solve this system of equation. So if we look at this system of equations, we can see the coefficient of x over here it is 1, the coefficient of y over here it is 2, and coefficient of z over here it is minus 3. In the next equation, coefficient of x is 2, y is 3 and z is 2. and last we have coefficient of x is 3, y is minus 3 and z is minus 4. These are the coefficients we have. So basically we can write this system of equation as Ax is equal to b, where A is this given matrix. So if we calculate the determinant of A, we can obtain the value of determinant of this matrix A, it is 67 and it is not equal to 0. So what we can see from this is that this matrix A is invertible, A inverse exists. If A inverse exists, then the value of x is given by A inverse of b. So in the first part of the question, we have to calculate the A inverse, and that A inverse we will use to calculate the value of x, that is to solve this system of equations. So first of all, we are calculating adjoint A. This is the value of adjoint A, this you can calculate. Then we have value of determinant is 67, we have already seen. So the value of A inverse we have, it is 1 by 67 minus 6, 17, 13, 14, 5 minus 8, minus 15, 9 and minus 1. So this is our first part where we have to find A inverse. Now we can use this A inverse to solve this system of equation where the value of x will be given by, we have to multiply over here the term, this matrix B, it is minus 4, 2 and 11. This is the matrix B we are saying, we have multiplied over here. So on multiplying these terms, we will obtain the value of x. So this multiplication is shown over here. We are having, this is the inverse of A and it is multiplied with the matrix B and we obtain the answer in this form. So these are the values of x, y and z. We are saying the value of x will be 3, the value of y will be minus 2 and value of z will be 1. So these are the three values we are talking about, that is the value of x is 3, y is minus 2 and z is equal to 1. Next is, these three equations are given, we have to solve these equations using the matrix method. So if we look at this second equation, it is basically 0x plus 2y minus 3z is equal to 3. So in matrix form, if we write, it is 3, 4, 2, 0, 2 minus 3, 1 minus 2, 6 into x, y, z. We are saying that is equal to 8, 3 and minus 2. So this is the value of A, x is equal to b. Now if we calculate the determinant of A, we will get it is equal to, we have calculated this value over here, you can calculate at your own and verify the results from here. We are saying this is, we have calculated the determinant of A and the value comes out to be 2 and it is not equal to 0. We are saying the determinant of A we obtain, it is 2 and it is not equal to 0. So A inverse exists. If A inverse exists, so we get x is equal to A inverse of B. So we have to calculate A inverse. Over here we have shown adjoint of A is this. Then A inverse is equal to 1 over determinant of A into adjoint A. This is the answer for A inverse. And to obtain the value of x, we have to multiply. To obtain the value of x, we have to calculate A inverse of B. This is the value of A inverse. We have multiplied it with B. This value we are talking about, we have multiplied it with B. On after multiplication, we obtain that this value x is equal to, we obtain this matrix x, y, z, this column matrix is equal to minus 2, 3 and 1. You have to multiply these terms, you will obtain this is equal to minus 2, 3 and 1. So what we get is x is equal to minus 2, y is equal to 3 and z is equal to 1. So these are the solution. This is the solution of this system of equation. It has a unique solution because determinant of A is not equal to 0. Next is using the matrix method, we have to solve the following system of equations. So these are not linear in x, y and z because x, y and z these are in denominator. So to make them linear equations, we are going to do the substitution over here, and the substitution is that 1 by x we substitute u, 1 by y we substitute v, and 1 by z we substitute w. So this system of equations, this first equation, this is transformed to 2u plus 3v plus 10w is equal to 4. This second equation, it is transformed to this form, and this third equation, this is transformed to the form 6u plus 9v minus 20w is equal to 2. Now corresponding to this system of equation, we are talking about these three equations, we can write 2, 3, 10, then 4 minus 6, 5, 6, 9 minus 20 into u, v, w. This matrix we are saying that is equal to 4, 1 and 2. So basically we have written it in the form a y is equal to b, where we have to evaluate the value of y. Now if we calculate the determinant of a, the calculations these are shown over here, we are calculating the determinant of a, the answer we obtain that is equal to 1200 and it is not equal to 0. So we are saying a inverse exists. So the value of y we have that is equal to a inverse of b. So when we calculate a inverse of b, this is the value of a inverse, we calculate the adjoint of a, we multiply it with 1 over determinant of a, and finally we have multiplied it with b. We have multiplied it with the value of b. On multiplying, we obtain the value of u, v and w. We obtain u is equal to 1 by 2, v is equal to 1 by 3 and w is equal to 1 by 5. We obtain these three values, and what we have assumed? We have assumed that x is equal to 1 by u, y is equal to 1 by v and z is equal to 1 by w. So we get that the value of x is equal to 2, value of v is equal to 3 and value of w is equal to 5. From these three we obtain the value of x, y and z as 2, 3 and 5. These are the values of x, y and z. These values we are talking 2, 3 and 5. So this is how we can solve this system of equations. Next is, we are given two matrices A and B. We are saying this is the matrix A given to us, this is the matrix B given to us. We have to calculate the value of AB. So if we multiply both these matrices, this is the matrix A and we are multiplying it with the matrix B, we obtain the answer is this. We are getting the answer on multiplying both these matrices. We are getting the answer as 800, 080, 00 and 8, and this is equal to 8 into 100, 00, 010, 00 and 1. So what we are getting is that A into B, that is equal to 8 times I. So what we get is that A into 1 by 8 times B is equal to I. So what this thing implies? We are saying A into 1 by 8 times B is I, means that A inverse is equal to 1 by 8 times B. We have obtained the value of A inverse, that will be 1 by 8 times B. So A inverse is equal to 1 by 8 times minus 444 minus 713 5 minus 3 and minus 1. Now we have to solve this system of equations. So if we look at these equations and we write them in the matrix form, we are writing it is 1 minus 1 1, 1 minus 2 minus 2, 2 1 3 into x y z, that is equal to 4 9 and 1. Now compare these two matrices. This is just the matrix A we are talking about. We are saying Ax is equal to B. A is invertible because A inverse exists. So we are getting x is equal to A inverse of B. The value of A inverse we have this. The value of B we have it is 491. So the value of x we have, the value of x, y, z we obtain it is 1 by 8 times these terms. So on solving this we get the final answer as 3 minus 2 and minus 1, and hence we obtain the value of x is 3, y is minus 2 and z is minus 1. So these are the three values we are talking about. X is equal to 3, y is equal to minus 2 and z is equal to minus 1. Next is the sum of three numbers is 6. So suppose we are saying the three numbers, they are x, y and z. Their sum is 6, means x plus y plus z is equal to 6. Next is twice the third number when added to the first number gives 7. So first number is this, twice the third number gives 7. So this equation can be written as x plus 0 y plus 2z is equal to 7. And the last equation we have over here, it is on adding the sum of the second and the third number to the thrice of the first number, 3x plus y plus z, the number we get it is 12. So this is our first equation. This is our first equation, this is second equation, and this is third equation. So we have to find the number, so we have to find the value of x, y and z. So if we write this in matrix form, we obtain that the matrix we have it is 1 1 1 1 0 2 3 1 1 into x y z, that is equal to 6 7 and 12. So this is the matrix A we are saying, this is Ax is equal to B. Now if we calculate determinant of A, the answer we are getting, if we calculate determinant of A, the answer we are getting it is equal to 4 and it is not equal to 0. So we can say that A is invertible. So A inverse exists. So the value of x is given by A inverse of B. Now we have to calculate A inverse. For that we have calculated adjoint of A. This is the value of adjoint A we have calculated. Then we have calculated A inverse. It is 1 over determinant of A into adjoint A. This is the value we have obtained. Then we multiply this value with the value of B. This is the value of B we have. We are talking about this value. We have multiplied this value with B and we obtain that the values of x, y, z. We obtain the values of x, y, z. These are 3, 1 and 2. So these are the required three numbers. Next is this system of equation is given to us and we have to solve it by using the matrix method. So this is the first equation, this is second equation, and this is third equation that is given to us. We have to solve this using the matrix method. So we can write this system of equation in the matrix form in this way. We have written the coefficients over here. It is 1, 1 and 1. Then it is 1, 2 and 3. Then it is 1, 4 and 7. Then the coefficient constant terms we have it is 6, 14 and 30. These are the constant terms we have. Now to solve this system, we are talking about, this is the matrix A we are saying, we have written it in the form X is equal to B. When we solve this for determinant of A, we obtain that the answer for determinant of A, it is equal to 0. So we have to calculate, the next step we have to do is we have to calculate adjoint of A into B. So we have calculated the adjoint of A. We have calculated over here the adjoint of A into B. This is the adjoint of A we have calculated. We know how to calculate the adjoint of A. It is, we have to write all the cofactors of the terms of the determinant and then we will take the transpose. and we have multiplied it with b. This is the value of b we have multiplied it over here. This term we have multiplied over here, and the answer we obtain in this case, it is the zero matrix. So we obtain that adjoint A into B is also a zero matrix. So both these conditions are satisfied. So this thing implies us that the system will have infinite solutions. So to solve this system for these infinite solutions, what we are going to do, we are going to write the augmented matrix over here. Augmented matrix means this matrix we are writing in this way. Augmented matrix means this part of the matrix. This is the new matrix we have written. This is basically the matrix A. This is the matrix A. This matrix. And this matrix, this last row we have, this last column we have added, this is the matrix B we have. Now to solve this system of equation, what we are going to do is, we are going to reduce this part of the matrix. We are going to reduce this part of the matrix to the simpler form, or we are saying in the row echelon form. We have not studied row echelon form right now. So we can just say that we are trying to make as many zeros over here as we can. We are going to reduce this matrix to some triangular form. For more details, you can refer to the videos related to the rank of matrices, echelon forms. These things will be more clear to you over there. So basically what we have done over here, with the help of this one, we are going to make both these terms 0. So we have performed the operation that row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So what we have done, we have made both these terms 0, these two terms. With this operation, we have applied these operation on all these elements. The next step we have to do is, with the help of this one over here, we have made this term 0 by applying the operation row 3 approaches row 3 minus 2 times row 2. So our matrix, in this matrix we obtain that this last row we have, it is equal to 0. So basically what we are doing is, we obtain the matrix in the form 1 1 1 0 1 2 0 0 0, and this part we have, it is 6 8 0. This part of the matrix, this is corresponding to A. This part of the matrix, this is corresponding to A, and this part of the matrix, this is basically the constant term corresponding to B. So now if we try to write the equations from this, if we again try to write the equations from this, we can see from this first part, the equation is x plus y plus z is equal to 6. From the second row, we have y plus 2z is equal to 8. Now if we suppose that the value of z we have, that is equal to k, where k is any real number, then the value of y, from this equation we are saying the value of y will be 8 minus 2k. If we substitute both these values, y and z, in this equation, we get it is x plus k plus 8 minus 2k is equal to 6. So we get the value of x is equal to k minus 2. We obtain the value of x is equal to k minus 2. The value of z we have, it is k, and value of y we have, it is 8 minus 2k. So we have obtained the solution over here, and the solution is, we can see it is z is equal to k, y is equal to 8 minus 2k, and x is equal to k minus 2, where k is any arbitrary constant. So we are saying if we substitute k is equal to 0, the solution we have, it is z is equal to 0, y is equal to 8, x is equal to minus 2. If we substitute k is equal to 1, we will get some answer. If we substitute k is equal to 2, we will get some answer. So k can be any real number, and corresponding to each real number, we can obtain different values of x, y and z, and these are the infinite solutions that we can obtain. And for more details related to these kind of problems in which we have infinite solutions, or the more type of equations where we have 2 unknowns and 3 equations, 3 equations and 2 unknowns. You can refer to the lectures related to the system of equations that we have done after studying the rank of the matrix or the echelon forms. So at this stage we leave this topic up to this.